Now, you are used to working with radicals. You've worked with square roots a lot. You've worked with cube roots a little bit, especially when we were doing sum and difference of cubes. But any other types of radicals you don't have a lot of experience with. And that's really what the basis for all of this section is to get you used to that and feel like you have a good idea of how to work with radicals. One of the issues that comes up, of course, is that you know your perfect squares, you know some of your perfect cubes, and that's about it. And so that's where it can get tricky, because when you're trying to find things to the 5th power, 6th power, that kind of thing, you don't really know those numbers. And so that's where having your calculator is going to come in a little bit handy. But you are going to have to simplify radicals in this section. So that's something that you're going to have to get good at, and we'll go through that a little bit. So for starters, you're going to have some problems like this. So we're just going to practice using our calculator. We're going to identify parts of the radical. They have names. We're going to use the names, and I'm going to show you what those are. I'm going to show you how to input different roots into your calculator, and that's what we're going to do with this particular problem. Okay, so I've given you 2 examples. We say that this is the 5th root of negative 43, and the second one we say is the 4th root of 71. So the only ones where we don't use the ordinal number, the 4th root, 5th root, I mean we could say the 3rd root, we just usually say the cube root. Okay? Now, let's talk about the keystrokes, and let's talk about some terminology here so we're clear. All right, so here's some terminology before we actually put it into the calculator. Okay, those 2 little numbers in the little notch there, if you will, of the radical, that's known as the index. So normally the square root, we don't have a number there. It's understood that the index is 2. Cube root, of course, there's a little 3 there. All right, so these little numbers here in the notch, in the little V, which you got to write small, and you kind of shove it in there a little bit. Okay, that's known as the index. The number underneath the radical is known as the radicand. Okay, obviously this little symbol is known as a radical. Okay. Now, in order to calculate the 5th root of negative 43, and I can just tell you right now, it doesn't come out even. It's going to be an ugly decimal, because you can't take a number to the 5th power to get negative 43. So here are the keystrokes in terms of entering it in your calculator. Okay, oh, and by the way, 5th root, 4th root, I mentioned that already. So here are the keystrokes. So for this first one, you're going to first enter the number 5, and then go to the math menu. So again, hit the math menu, and the 5th one down, I think, looks like a radical with a little x in it. Okay, and so when you hit that button, what should happen is the 5 slides in as the index. And then, of course, you can just type negative 43. Be careful. Don't use the minus sign. Use the negative sign. The math menu. The math button. That says math. It's next to, it's underneath the alpha key. Right underneath the green key is the math button.
3 around this big. 1, 2.
Yeah, you can do 2 or 3 places. Okay, and so that's where in the math menu there's some of those, I don't know, odd symbols that we don't always use, but they come up occasionally enough. That's a good place to look for those kinds of things. Bless you. And then once you've done that, round it to 2 or 3 places. I think I rounded mine to 3 places. Okay, and write that down and see what you get. Make sure we're all on the same page. Should have gotten negative 2.122. Raise your hand if you got that. That's all you have to do for problems like that. Anybody having issues getting that typed in their calculator? Again, when in doubt, go to the math menu. Most of the time, you're going to have to press the index first and then hit the math button. All right. So then go ahead and do the next one, the 4th root of 71. If you didn't already. So that's just practicing using your calculator, seeing what it can come up with to get those numbers. Okay, what is it? Just say it.
2.9.
Okay, 2.903. Now, Kenzie brought up a point earlier that I want to kind of address. She said something about, well, we don't have to worry about imaginary numbers or anything when we got a negative under the radical. The only time you have to worry about it is if the index is even. Okay? Because I can take a negative number to an odd power, and now I'll get a negative number. But you can't take a negative number to an even power and get a negative number. So that's the only time you kind of have to watch out, is if the index is even and you have an odd number underneath that. That's the only time you got to look out. I mean, think about when we were doing this to begin with. It was a square root of a negative. Well, square root, the index is 2, even index. Okay, we'll get to that a little bit more in a minute. Questions so far? That's the easy part. Okay, now let's talk about how to simplify a couple radicals here. Now, for this first one, a says plus or minus the square root of 16y to the fourth. Now, we would only expect to see a plus or minus in there is if it was in the context of an equation. Okay, so I probably had an x squared somewhere. I take the square root of both sides. That's where that plus or minus comes from. Now, they've already given that to us as part of the problem, so it's not that big a deal. I'm going to show you 2 different ways to do this problem. The first way I think is a little more complicated, but that is the basis for it, and then I'm going to show you a trick. And I'm going to show you the trick because once we see the foundation of this, I think it just saves us some time. All right, you are not obligated to use my trick, but if you want to, you can. All right, so here's how I want to approach this first problem. Let's not worry about B right now. B's a little trickier. But here's the way I would approach this first problem. Okay, first off, let's remember that for a square root, it's understood that the index is 2. We don't write it, and you don't need to write it, but let's just make sure we're all on the same page with that understanding. Okay, because of that, what I want to do is look at this in parts. Right? The plus or minus is just hanging around. It's just there. We know what the square root of 16 is, yes? Very good, class. Easy enough, right? Now what do we do with the y to the fourth? So let's think about what we did to come up with 4. The numbers are easy. Hopefully what you thought was, what number to the second power gives me 16? Did anybody think that? Raise your hand if you thought that. How many of you just know the square root of 16 is 4 and you don't have to think about it anymore? Right, okay. So that's the thing with this section, is when we're dealing with square roots, a lot of that is just sort of second nature. The bulk of this section won't be. Okay? So get in the habit of thinking through what it means. What number to the second power equals 16? Now I got to do the same thing with the y to the fourth. Okay? I have to ask myself, what number to the second power equals y to the fourth? Say that again, but louder. Why do you say that? Why do you believe that is true? Okay, and why would you multiply the 2's? Power to a power, thank you. So in reality, what I'm doing here is I'm going, what number raised to the second power gives me y to the fourth? And because of our power rules, and you have power to a power, you do multiply those powers. Okay? So in the end, that's my final answer. And if you wanted to check to see if that was right, all you have to do is square this. Is 4 squared 16? Yes. Is y squared y to the fourth? Okay. When we get into the variables, that's where it's going to get a little tricky for you. Okay. Any questions on that? Now, I'm going to show you something up here for this problem, again, which is foundational. You don't necessarily have to write it out that way like we did for this one, but I just want you to see this. Okay. In reality, what we're doing is what number squared gives me the 16y to the fourth. Because as we've been learning about, and this is how it connects back to what we've been doing, we have inverses. We want the square root and square to cancel. Those are inverse operations. So I have to figure out what number to the second power gives me 16y to the fourth. That's the concept. And that's how it connects back to what we've been doing. Because they are inverse operations. And so it's just a matter of figuring out what number squared gives me 16y to the fourth. So 4y squared, as we've gone through already. Okay, so that's what it would look like. That I had it in red and green. They cancel out. Boom. Plus or minus 4y squared. I only highlighted the plus or minus because it's just hanging around. Like it's probably the right side of an equation where we tried to solve. But it's really not that. You're not going to always have a plus or minus in these kinds of problems. Okay? It's only there because it was given to us in the problem. All right. So we're going to go through the same process in B, except what I need you to do, what I need you to think about when you do this problem is that this whole thing is not two terms. Think of it as just one thing in one group. One group to the 8th power. Okay, so I'm taking the square root of something to the 8th power. So what I need to be able to do is figure out what number squared will give me something to the 8th power. So here's by that. Okay. What number squared will give me something to the 8th power? Because the square root and the squaring are going to cancel out. Then after we get through this problem, I'm going to show you my trick.
What do you mean?
You'll see. What number squared is something to the 8th power?
That just doesn't go through my head very well.
And this is why we're learning this today. We're going to practice it. Okay, so here's another way to think about it. What? Okay, let's rewrite the problem just to think about it. What if I said this instead of x squared minus 8, right? So then I'm thinking, just make it y because it's a different variable. What squared equals y to the 8th? Now, Mackenzie. Y to the 4th, right? Y to the 4th squared equals y to the 8th. Well, the key thing here is that the square root and the square cancel, and I just get y to the 4th. Except it's not y. There's no y in this problem. Right? Y represents what in this problem? X squared minus 6. So I'm thinking, again, this is that whole idea of thinking about it as one whole thing. Right? We don't have to multiply anything out. We don't have to take x to the 2nd minus 6 to the 8th. We don't want to do that. It's just one quantity raised to the 8th. So I can think about it this way. Now, okay. When I rewrote the problem this way, I basically substituted y in for x squared minus 6. I got rid of the x squared minus 6 to think of it in a simpler way, because it is just one thing. Yes?
So, the x squared basically didn't matter?
It's just, we're saying it's the group is to the 8th power. This group is to the 8th power. The x squared minus 6 is the group. But we're not really doing anything with it. It's the group to the 8th power, so that's what I have to simplify. Which is why I use this over here. You have to be able to start seeing this not as two different terms, but as one group. And then I use the strategies that I used over here the same way as I used over here, except we thought of this as one group. And if this is a way you want to think about it, then think about it that way. Okay. Okay, hold on.
So if it was,
Go ahead. Yeah, go ahead.
So if it was just x minus 6, would it still get you x minus 6 to the 4th?
Correct.
Okay.
Yep. This could be, I don't know, a zebra. 4 zebras and an apple to the 8th power. That's not even the point. The point has to do with the exponent. Okay? So in reality, what I have here, this y really is x squared minus 6 all to the 4th. And so that's why it all cancels. Okay? So what I really have is this. Now, let's just this x squared minus 6 to the 4th. And this negative is just like this plus or minus. It's just hanging around. Nothing happens with it. Okay?
How did that get there?
Well, we thought about it like it was y, one thing.
Yeah, but
This whole thing to the fourth, to the second, then the square root, and the square cancel.
What about the x and 2? Why didn't it do
Because it's just one thing. It's just the same way as this problem we had here. It's the same. Hung up on that because that's only one kind of problem we're going to see. But I want to teach you about the trick now. Because the trick that we're dealing with is the powers. And the powers are what's hanging you up. All right? So, for example, I want you to notice something. I should be right here. Okay? So, what I've done is I wrote the index in both. And I highlighted the power on the variable. And I want you to see if you can come up with a relationship between the power, the index, and the final answer power. The power, the index, and the final answer power.
We don't have the final answer.
We do have the final answer.
Half of what the original.
You just divided. Yeah.
Yes and yes. So, Braden, say what you just said. Half of what, and then Emmeline, what did you say? You divide them. Now, here's why I like Emmeline's answer better. Your answer, Braden, is good for this problem. And it's good for this problem because the index is 2. That's why it's half. But Emmeline's answer is more across the board. So the trick here, when you're dealing with variables, and you're dealing with their powers and the index, if you divide the power by the index, that will give you the power of the final answer. So this is not a coincidence. So instead of having to write it all out and going through all the steps of what to the whatever power gives me this, the trick is, if you divide the power in the radicand by the index, you will get the power for the final answer. Now that doesn't work for the number. That doesn't work for the coefficient. It only works for the powers. So in this particular problem, I could have gone right from here to here by just dividing these. 8 divided by 2 is 4, and copy that down, and the minus copies down too. Okay? Now, that's the trick. Like I said, I think that's what you're going to like. And actually, later on in this section, I'm going to explain the trick. It's not really a trick, but I will explain it later on in this chapter. All right, let's go on to some other problems. So here are the kind of problems you're going to see in your homework. Okay? So this is the fifth root of 243, a to the 20th, b to the 25th. And this one is the square root of negative 16, x to the 4th, y to the 8th. Actually, try the first one. Try C on your own. Don't discuss. Just try it on your own and see what you get. If it's wrong, it's okay. But I think you'll probably get really close. I will give you one hint. Think of them as 3 separate problems in one here. Think of it as 243, a to the 20th, b to the 25th as 3 sort of separate problems in one. I'm very impressed. Well done. Okay. So, now, I don't expect you to know that the fifth root of 243 is 3. I expected you to go to your calculator and plug it in and see what you get. Okay. And then you found out that it was 3. Okay, that's good. The rest you should be able to do in your head, right? 20 divided by 5 is 4. 25 divided by 5 is 5. And that's it. That's the trick, okay? So what hopefully you got was 3, a to the 4th, b to the 5th. How many got that? Very good. Okay?
So for these ones we don't.
So that's good. Now, again, if you wanted to, foundationally, to figure out where this comes from, what this means is if I took 3a to the 4th, b to the 5th, and it was all raised to the 5th power, and I took the 5th root of it,
You get that.
yeah, they would cancel out, and I'd be just left with this. And that's what this is here, okay? But I don't expect you to write this out. I'm just showing you this. You don't have to write it out. You can use the trick that I showed you to go right to the answer. I think you'll like that better anyway, yeah? Okay? Now, D, go ahead and do that one. Some of you already did do that one, but go ahead and do that one. This one's a little trickier, but not too bad still. Again, it would be helpful to think of this problem in 3 parts. Think of that in 3 parts. That'll make. This one also looks good. So the trick here is, and this we alluded to this before, if I have an even index, which I do, because what is the index? 2. The index is 2. When I have an even index and I have a negative number underneath, we have a problem. In this case, we can take the square root of a negative because we learned how to do that in chapter 4. What is the square root of negative 16?
4i.
4i. Okay, then the rest I can do like we did. 4 divided by 2, 8 divided by 2. You should have gotten 4i x squared y to the 4th. Raise your hand if you got that. Very good. And again, here's where the distinction comes in. Okay, so let's talk about that for a sec. If I take the 5th root of negative 43 and it's negative 2 point whatever it was, if I multiply those together, 5 times, I can take a negative times a negative. There's a positive. So this gives me a positive. This gives me a positive, and I got a negative left over. So a negative times a positive is a negative. There's no issue with that. The problem is I can't ever take a negative multiplied by itself an even number of times, 2 times, 4 times, 6 times, 8 times, to ever be negative. It can only always be positive, unless we're dealing with imaginary numbers. Okay, so that's the distinction. That's why there's a difference between an odd index and an even index. Because when it's an even index, you can't multiply anything by itself an even number of times and get a negative. You can't. You can only get positives. But for an odd index, you can multiply a negative by itself an odd number of times and get a negative, or you can multiply a positive by itself an odd number of times and get a positive. So you can get positives or negatives when the index is odd. But when it's even, that's when you have to be on guard. And that's what this next section is about. Notice, this is 4 variables. We're talking about variables. Okay, there's one case when you have variables underneath a radical that you have to be alert. And that's the even, odd situation. That's what this is. Okay, when you have an even, odd situation, your guard has to be up. Because if that happens, there's a possibility you're going to have to alter one of your answers. And I'm going to show you how to do that. You should absolutely write this down, though. And we'll talk about what it all means. But I'm going to say even, odd a bunch of times. And I want you to get that ingrained in your head. When you start dealing with radicals with variables, get that even, odd ingrained in your head. Because when that situation happens, you have to do something different. That's the only situation. The only case. So, when you find an even root of an even power, meaning, here's what this means. The index is even, the power in the radicand is even, and your answer gives you an odd power, you have to use the absolute value of that. Because we have to ensure that our answer is non-negative. Because we can't have a negative under the radical when the index is even. Okay, so understand that when we talk about i's, we're only talking about the square root of a negative. Square root only, not 4th root, not 6th root, not 8th root, only square root. But we can have 4th roots and 6th roots and 8th roots and 10th roots. We can have that. And those are the ones we have to look out for when it comes to the variables. So when I say even, odd, here are the conditions. The index is even. The power on the variable underneath the radical is even. And when you divide those two, because that's what we do, right? You divide the power of the variable by the index. If the power of your answer ends up being odd, then you're going to have to put some absolute values in. And I'll explain why when we look at our first example. Okay, so that's what even, odd is. Even index, even power on the variable under the radical, odd power on the variable for my answer. Okay, so look at an example. Again, as I've said before, if you're finding an odd root, it doesn't matter. You don't have to worry about any special whatever. You can have negatives or positives, it's fine. So you don't have to worry about the absolute value if the index is odd. You potentially only have to worry about it if the index is even. So, here are the 2 examples we're going to look at. Right? You look at A and you're like, that's pretty easy. Right? You all know the answer. You're looking at it right now and you're like, easy, no problem.
Is it y?
I don't know. Is it?
I don't know. That's what
That's what I'm asking.
Now we're up.
All right. Braden says, is it y? Is it?
Yes.
Is it?
Yes.
Yeah, I mean, divide 4 by 4. It's y. Y the first. Right? Easy enough. However, you knew there was going to be a but, didn't you? Okay, so, no, there's no plus or minus. Here's our issue. The index is even or odd.
Even.
The power underneath is even or odd. Okay, so here's where you got to be on guard. You're like, even. So far, it's even. If my power on my answer ends up being odd, we could have a problem. 1 is definitely odd. Here's why. Okay, here's why. Okay, so because technically, I mean, the power is 1. So I have an even, odd situation here. Even index, even power, odd power as a result. Now, here's the reason why. We do not know whether y is positive or negative. We don't know what it represents because it's a variable. So it could represent any number of numbers. The one thing we don't know is if it's negative or not. And if y is negative, we have a problem. Because you can't take the square root of the 4th root of the 6th root of the 8th root of any number and spit out a negative. You can't. It can't be done. Okay? So again, we have even, odd here. And so what we have to do to guard for that is we just put that y in absolute value. So even if y was negative, as it turned out, we force the answer to be positive. Okay? And here's the other reason why. If y was negative and I raised it to the 4th power underneath, would I get a positive or a negative? I would get a positive. So it would be disguised even still. But yet if y was negative, we would have a problem. So when I have this even, odd, I just take that part that is the even, odd and put absolute value around it. And that's what it says here. Okay? Since y could be negative, we don't know. We're not going to know the value. But because y could be negative, you take the absolute value of y to identify what's called the principal root. And again, we're just trying to ensure that I don't get an output that's negative. So we safeguard it by putting the absolute value around it. Yes?
Are we ever going to have to explain this is why?
No, I don't think so. But you should know why it happens.
Wait, what does this little paragraph mean?
All it's saying is that we don't know whether or not y is positive or negative. It's just a variable. And we know that you can't take the square root of a number or the 4th root of a number and the 8th root of a number, whatever, and it produces a negative. It's like, okay, for example, early on when we had that problem that had the square root of 16, not one of you said -4. You all look at that and you go, 4. We all know that. It's understood. Okay? And so that's what the principal root is. It's the positive root. The principal root is the positive root. Okay? And so we have to do the same thing. Because we don't know whether y is positive or negative, we safeguard it and we just put it in absolute value. Okay? Now, let's look at the second one. It only applies to the variables, the even, odd thing. Okay? So the first thing I want to do is split it and think about it separately, right? 6th root of 64. Might need your calculator for that one. Maybe not. Do you know that, or did you guess?
I'm pretty sure it's 2.
Mm-hmm. What is it? 6th root of 64. 2. It is 2. So that part's done. Okay? And I don't have to worry about even, odd. It only applies to variables. Do I have to worry about even, odd here for the next part? Okay? Index is even. The power on the variable is what? Even. 18 is even. Okay, so I have even. Now, if when I divide them I get an odd, then I'm going to have to use the absolute value. Do I get an odd power when I divide them? Yeah, you bet I do.
3 is odd.
Correct. Even, even, odd. Now, again, I don't know what the value of x is. So what we do, and now here's the tricky part. You only put the absolute value around the part that is the even, even, odd. So I don't need to put it around 2. 2 is positive. What I have to do is put it around the part that had the odd power. Okay? So the only thing that has the absolute value is the odd power result.
Wait, so doesn't 2 have an odd power then?
It only applies to variables. And 2 is positive. Okay? Again, 2 is positive. So I don't have to worry about it possibly being negative. It is literally a positive number. It's just the even, even, odd variable part. And so you're going to have to look out for that. That's the part you have to look out for. Question?
So all you do is put
Okay, listen, please.
Why doesn't the 3 like go to the x squared and then negative 3?
Because it's in parentheses, right?
Because again, like our first problem that we looked at, or one of the first problems, correct. It is one group to the 18th power. Okay? Now, I could, if you really wanted to, you could multiply this out, multiply it out. You know, it's x squared minus 3, x squared minus 3, x squared minus 3, and multiply that out. But please don't do that.
So
That's just extra work. You don't need to do that.
all you do is put it in absolute value.
Put that part in absolute value, correct.
That would be way more easy to explain.
Well, but the problem is you have to understand, 1, why we do that, and 2, that it only occurs in that specific situation. So you have to be able to recognize it. Because in every other situation, you don't have to do it. So just be careful for that.